Yeah, so these are also the frequency is between 30 and 300 hertz, as you see on the chart there. But then what's important to understand is the wavelength as well. So 10,000 down to 1,000 kilometers. So these are very long wavelengths, wide wavelengths. And so when they're that wide, the electric field is actually separated out from the magnetic field and they behave differently. And so it's not together like RF. You can test the magnetic or the electric field of RF and kind of get a similar thing because similar reading because they're together. They're so tight. But with these wavelengths, they're so far apart that the magnetic and the electric field can be measured separately,
Mm.
and they behave very, very differently. So a lot of us know about a typical magnet, like a little magnet like you'd have like right here.
I just go live on your on full screen.
Yeah.
Yeah.
So so this magnet is kind of like the Earth. The Earth is a big magnet and it spins. And so if this is spinning like that, it's kind of like how the Earth spins, right? And this is only going out in one direction. There's, if we could see the magnetic field, it would kind of be spiraling out from here. And a lot of us have played with those little iron flakes when we were kids in science class, and you can actually see the magnetic field and the lines and everything that's creating. So this kind of magnetic field, the difference between this and the magnetic field that we're talking about from man-made electromagnetism is that this is not pulsed. The Earth is not a pulsed frequency. And so the frequencies that we have from the wiring in our walls, from the power lines, from motors, those are pulsed frequencies, and they're pulsing at that 60 hertz or 50 hertz if you're in anywhere besides the United States. So we're getting this constant pulsation of this energy, and it's something that humans have never been exposed to before, much like we've never been exposed to vast amounts of radio frequency. So so basically kind of understanding the difference between those magnetic field sounds like when it's pulsing and everything. But it, the basics of what I like people to kind of visualize is that if you, and this may be kind of grotesque, but if you were able to burn down any biological form, whether it's a plant or an animal or whatever, and you just have a pile that's left over, that pile is made up of just minerals. You'd have basically minerals. So our, like everything that we see, all of matter is made of various minerals and elements. And those minerals, every single one of them has a relationship with magnetism. It either aligns with the magnetic field or it disaligns from it. And there's really no in between. So when you think about that and the way how our Earth is a big magnet, a DC magnet, it's emanating out from the Earth in one direction, and it's analog. So it's not pulsing, it's just going in one direction. And we're either aligning or disaligning from that magnetic field. And our whole body is made up of minerals. And so one of the easiest things to visualize is that your red blood cells have hemoglobin, which contain iron. And we know how iron reacts with a magnetic field. It's attracted to it. So just like this, right? So when you have that attraction, it's aligning or disaligning with that magnetic field. So you can actually pull red blood cells with strong magnets through the body. And so if you can imagine that when we have this foreign oscillating pulsating current that's going through our bodies from this source of man-made magnetic field, on this microscopic level you have all of these minerals in your body that are reacting to that. And so it has a profound effect on a cellular level of how your cell is going to behave, how the different organelles inside of your cell are going to behave. And it causes dysfunction, something that's outside of the norm for what humans have been exposed to or been evolved or created to be around since our time on this planet. So some examples of magnetic fields, significant magnetic fields that you find in the home is like anything with a motor running. If there's a wiring error in the house, then that's something that we often will hunt down in people's homes during our assessments. Is we'll hunt down the wiring errors that are created, because if your home is wired without any errors, there shouldn't be any magnetic fields whatsoever. And it's about balancing the hot and the neutral wire, essentially. And if that's not balanced, then those wires aren't canceling out the field from each other. They kind
And
of balance each other out.
Brian, you were mentioning something that I think is important on how to differentiate between electric and magnetic field, is that the magnetic fields in the home are more, let's say, static. They don't move around like electrical fields. We saw how you touch maybe the power bar and it kind of goes on your body, right? It jumps, where the magnetic field stays in one place.
Right, exactly. So you could think of electric fields as like electric fields are always shifting with when there's a voltage change or there's conductive surfaces. It wants to climb on anything and reach the lower voltage potential. Whereas a magnetic field is just kind of staying where it is, and it's created from current that's flowing. And so if there's what's called a net current, where there's current flowing in one direction but not another direction, and it's not canceling out that current, there's what's called a net current, which means that it's an unbalanced current, and that's what creates this magnetism coming off of that source. So a lot of people have like metal water pipes that are installed in their house, and the whole grounding system of the neighborhood and your own house is connected to those pipes, and they're using those pipes as a common ground for the entire neighborhood. Now, when your whole neighborhood is dumping, if there's any wiring errors anywhere in the neighborhood, then they're dumping that net current onto those pipes, and it's going onto the pipes of every single home in the entire neighborhood. And so there's generally, wherever those pipes are, because there's a net current, there is a magnetic field. And then also in motors, magnets spin around, and when they spin, it's oscillating. It oscillates, and so it's pulsing. And if you have a magnetic field, that's why you have magnetic fields from motors and anything that has a motor in it or a magnet that's spinning around. Even tires from cars, they have a magnetic field because the tires are spinning. So and it creates this pulsation. So but the magnetic field is static. It's not jumping onto things like electricity does. So if you get out of that field, then and you can actually have a good biological distance from that, and you're out of it. And our standard is we read it in milligauss, and we like to see it in daytime areas around 0.5 milligauss or less. And in nighttime areas, we like to see 0.3 milligauss or less. Now, there's some experts that have studied this extensively from a biological perspective, and they've studied it much more extensively than me, like Dr. Paul Heroux. And he says that he's detected in his studies that even at 0.2 milligauss, there can be a biological action that happens.
At extremely low levels.
Yeah, at extremely low levels. So we even recommend shielded healing. I mean, we're like the top, we have the strictest levels of anybody, and we're recommending 0.3 or less. But Dr. Paul Heroux, he says that even, a biological change can happen at 0.2 milligauss or less, which is 20 nanotesla, or and that's extremely low. Sometimes that's considered like almost nothing. I mean, in my house right now, I'm at 0.12 milligauss. So I'm below that.
And
But
that's very good. That's very low from, well, just average readings that I've been taking. And